Good morning and welcome to Mission Control Houston and Space Station Live. It's another day of progress unpacking, HTV preparations, science experiments, and maintenance activities in space today. The International Space Station Flight Control Team is watching over all of this from here on the ground in the International Space Station Flight Control Room, where they're led by Flight Director Dina Cantella, with Serena Anyan in the role of Capcom today. In space, the Expedition 36 crew is more than halfway through their day, which began at 1 a.m. Central Time. They are Russian Commander Pavel Vinogradov, U.S. flight engineers Chris Cassidy and Karen Nyberg, European Space Agency flight engineer Luca Parmitano, and Russian flight engineers Alexander Misurkin and Fyodor Yurchikhin. Cassidy, Vinogradov, and Misurkin have been in space and at the space station since March 28th, putting them at their 123rd day mark of the mission. Nyberg, Parmitano, and Yurchikhin, meanwhile, launched and docked on May 28th, so they've now spent 62 days in space and at the station. Together, the crew is currently orbiting 258 miles above the Bay of Bengal and heading toward the coast of Burma. Looming large again on the crew's agenda today is more preparation for the upcoming launch of the Kounotori H-2 Transfer Vehicle number 4. That Japanese cargo vehicle is scheduled to take off from the Tanegashima Space Center in Japan at 2:48 p.m. Central Time on Saturday. And flight engineers Karen Nyberg and Chris Cassidy spent some additional time today training to capture it using the space station's robotic arm and pulling it to the space station for berthing at the Harmony node. That berthing is scheduled to take place on August 9th. Meanwhile, Commander Pavel Vinogradov is spending most of his day unpacking another cargo vehicle. That's the Russian Progress 52, which arrived on Saturday carrying almost 3 tons worth of supplies and equipment that he's been working to unload and get entered into the space station's inventory management system. His fellow Russian crewmates have a couple of different science experiments planned for the day, including one that looks at developing technologies to produce biomasses of microorganisms and one that studies how interleukins react to germs in microgravity. There are several science experiments going on the U.S. side of the station as well. Parmitano and Nyberg are both taking part in the reaction self-test again today, looking at how fatigue affects their performance. And Parmitano is also continuing his current run of the Pro-K experiment, which looks at how an astronaut's diet can decrease their bone loss during long stays in space. In addition, Cassidy is joining them today for another segment of the ocular health experiment. All 3 astronauts are performing fundoscope exams of their own eyes in an ongoing effort to document the changes in astronaut vision over the course of their expedition. That's what's going on in space today, and this is Mission Control Houston.
If you guys are happy, then I can start a little early.
RSS Moscow, Nezhevon.
And Luca, copy all. Give us a couple minutes to send a few commands, and we'll let you know when you're go to press.
Awesome. I will be standing by. Thanks.
Houston Station on 2 for robot. Go ahead.
Another funny that happened while we weren't touching the computer, the lower display or the lower computer lost a lot of the windows went away, and as well as our e-stop button. So what should we do to restart the sim or to stop this sim?
Checking.
Today marks an interesting anniversary on board the International Space Station. It's the 2000th day in space for the Columbus module. That's the European Space Agency's laboratory that arrived on board STS-122 back in February of 2008. Though the crew isn't really doing anything in particular to celebrate that anniversary, flight engineer Luca Parmitano, who of course is the European Space Agency astronaut, did do some work in there today on the inside the Columbus laboratory on the laboratory's thermal control system. He was working to remove gas bubbles from that system's water loops, and you can see his work from earlier this morning here in this video. Again, it's the 2000th day in space for Columbus. That is one of several laboratories on board the International Space Station. This one, again, the European laboratory in particular, and it is 22.6 feet by 14.7 feet and provides a number of different experiment homes for some of the science that goes on board the space station. It's a multifunctional pressurized laboratory that supports scientific and technological research in the station's microgravity environment and also performs a number of technological applications. Some of the research areas that it's used for include fluid physics, material science, and biosciences. And it also has an external facility that can host space science, Earth observation, and technology experiments, as well as applications for the vacuum of space. As I said, it came to the space station during the STS-122 mission aboard Atlantis in February of 2008 and was installed using the space station's robotic arm during a spacewalk on that mission. Now getting some live video from inside another laboratory on board the space station. This is the U.S. Destiny Laboratory, home of one of the two robotic workstations that the space station houses. You see just here in the bottom corner of the screen, flight engineer Karen Nyberg, who is working again with flight engineer Chris Cassidy on their training for the arrival of the Japanese H-2 transfer vehicle number 4. The vehicle is scheduled to launch on Saturday and then arrive at the space station on August 9th.
At every second row, and I can see that there is out of sync between the frames, and also we have some plane and horizontal rows speaking simultaneously. So we have some instability both for the frame as a whole and speaking simultaneously. When we just had a display, it was much better. Okay.
One of the experiments that the crew has taken part in today, in addition to this work they're doing to train for the arrival of the Japanese transfer vehicle on August 9th, is working to perform eye exams on their self as part of the ocular health study. That is experiment with the subtitle of Prospective Observational Study of Ocular Health in Space Station Crews. It's aimed at systematically gathering physiological data to help characterize the risk of microgravity-induced visual impairment. About 20% of astronauts living on the space station have reported some changes in their vision after their flight, and so teams here on the ground of scientists and doctors are working to figure out exactly what's causing that. They've reported they see in the astronauts a flattening of the globe of their eye, as well as a swelling of the optic nerve, and a far-sighted shift, as well as colloidal folds.
I understand you have 1 minute.
It's thought that some of that could be the result of increased intracranial pressure that's caused by the shift of body fluids from the lower body to the upper part of the body while they're in microgravity. And there's also some thoughts or data that suggest it could be linked to a vitamin B12 or folate deficiency. In the past, comparing blood analysis with nutritional assessments revealed that crew members who experience vision changes had consistently lower folate levels and higher levels of metabolites. So all of that is part of the study, but in addition, the crew is performing, while they are on orbit, a number of different eye exams. Yesterday, they performed kind of the standard exams that you would take here on the ground with just an eye chart, checking out, doing a regular vision test, and then also did some blood pressure measurements and tonometry measurements on their eyes. And today, all three of the U.S. and European crew members used a fundoscope to examine their eyes. That was delivered on SpaceX 2 back in March and first used just last month. Fundoscope is an instrument that examines the inside of the eye, in particular the retina, using a mirror that reflects light into the eye and a central hole through which the eye is examined. It's just one more way that the doctors here on the ground are able to gather information on exactly what is going on with the crew's vision while they're in space as part of this ocular health study. It's an important question to answer because as NASA begins to expand its exploration further into deep space, the missions that astronauts will be going on will get longer, and it becomes more important that we understand exactly what to expect with their vision as they go further away from Earth and stay away from Earth longer. And of course, we'll need to be able to see well on the journey and once they arrive at the distant destinations we plan to explore. In addition, the information that comes from the experiment could also be relevant for patients suffering from eye diseases here on Earth, such as glaucoma, and diseases of the brain, such as hydrocephalus and idiopathic intracranial hypertension.
Center and horizontal noise. And the noise are as follows. They're horizontal. slowly crawling down, and the screen is shaken. In other words, I would call it horizontal offset of the screen. It's like another page is trying to get through. Okay.
Continuing to see here a live view of Karen Nyberg at the robotic workstation at inside the Destiny laboratory. This is looking at one of the many views they use or the many training tools they use as they prepare for grabbing onto the HTV-4 when it arrives at the space station on August 9th and using the space station's robotic arm to guide it in for a berthing on the Harmony node.
16 minutes until we'll turn off the progress assets, stop the recording, and then let's work with step 3 through the ISS and Soyuz. Speaking simultaneously. So I can turn it on, inaudible. I'll call you. Yes, we'll be standing by.
Nyberg and flight engineer Luca Permitano started one of their science experiments for the day very early this morning. They ran their first reaction self-tests for the day as soon as they woke up and plan to do another just before they go to sleep tonight. Full name of that experiment is the Reaction Self-Test Psychometer Vigilance Self-Test on the International Space Station. It is a 5-minute activity that allows crew members on the space station to monitor the daily effects of fatigue on their performance, helping them to identify when their performance is degraded by fatigue-related conditions that can occur as a result of living in space. It could be problems sleeping, shifts in their sleep schedules due to activities that are going on board the station, sleepwalks, and extended periods of activities without days off. To test that, the crew members perform 5-minute tests before and after their missions, as well as during the mission. The test involves the presentation of a series of randomly timed visual stimuli displayed on a laptop screen. The crew responds to them by pressing buttons on the keyboard, and their reaction times are recorded. The test will hopefully help crew members objectively identify when their performance capability is degraded due to fatigue, which is a high priority for NASA's behavioral health and performance research. It's another experiment that's going to be more important as NASA ventures further away from the Earth in its exploration, and its human exploration in particular, as it'll be more incumbent on the crew to judge their readiness for some of the activities that they'll have to perform as they move further away from Earth and contact with the team here on the ground begins to experience delays due to the distance. In addition, the 5-minute test is derived from an original 10-minute psychometer vigilance test, which could also be used to measure lapses of attention, wake state instability, impulsivity induced by fatigue, and other performance-degrading factors here on the Earth.
Okay, we understand it all. Thank you. All right, that's it.
Да, сейчас мы переключим еще ту антенну, через которую сейчас принимали еще на СБ. Сейчас мы на ту антенну принимали грузовик на...
Switch it back to the antenna which we used to receive the signal from Progress. Yes, I understand. You're about to check all the station assets. Yes, understood.
МКС по Москве в канале СГ-1.
ISS Moscow is Jovan for Fedor. Go ahead.
Ну мы переключили.
Okay, Fedor, we switched to a different antenna. What's the quality?
Качество, знаешь, вот
You know,
может быть переключение.
probably at the actual moment of switch and the digits got a bit dimmer, but now they're bright back again. Very clear image. We can see crosshairs and we can see very clear format 44. Copy, Fedor. Thank you very much. I understand you recorded it all and you have it on a USB drive. Yes, actually the recording is still in progress. Okay. You can stop the recording now.
Yesterday we had some updates on the troubleshooting work that's going on here on the ground with the help of the crew on board the station, looking at what exactly happened during the July 16th spacewalk with Luca Parmitano's spacesuit. During that spacewalk, he began to notice a water leak inside the spacesuit and experience a buildup of water inside his helmet that called for the spacesuit to end, or the spacewalk to end early. And since then, teams here on the ground have been working through possibilities on what might have caused that, trying to determine what was wrong with the spacesuit. Last week, they got some help from that, from the crew on board the space station. We have a video of Chris Cassidy discussing the spacesuit and exactly what happened that we're going to play for you here next on NASA TV. This is Mission Control Houston.
Hi, I'm NASA astronaut Chris Cassidy on board the International Space Station. And last week, myself and Luca Parmitano did a spacewalk in which we had a problem with the inside of his suit. There was leaking cooling water somehow into his ventilation system, and that water got into his helmet. Don't know the exact specifics right now. The engineers and all the people in Houston are working on the problem and trying to figure it out. We'll do some troubleshooting soon, but I wanted to show you where the water was coming from. So this is Luca's helmet, and the ventilation air comes into the helmet through this port right here, and then goes behind the crew member's head, and then blows the air across the front of your face. Well, with water, a mixture of water and air getting into this vent port, the water bubbles started to build up behind this white plastic piece. Once the water got big enough that it went all the way around and started coming outside the edge of the white plastic, then it saturated his communication cap, and sort of capillary flow just brought the water all around his head, and he had water on and it filled up in his ear cups, and it started to creep into his eyes and covered his nose. Scary situation. the ground teams worked really well to give us some direction, and as a team we got everybody back and everything was fine. But the water would continue, if it had continued to leak much more, it would have been really serious. So that was our problem, that was our spacewalk. It planned for 6.5 hours, and it was about an hour and 45 minutes or so. So don't know if we'll be able to reschedule, but we'll see. And the most important thing is that the suits are determined to be safe, so that whenever the next folks get outside, that everything works well for them.
Would you like me to terminate TV?
That again was Chris Cassidy in the recorded video explaining what took place on July 16th with Luca Parmitano's spacesuit. He and the other crew members have been helping the team here on the ground go through their fault tree as they look for the root cause of the water leak that Parmitano experienced. And the team has isolated the failure to the spacesuit's primary life support system, which is essentially the backpack of the suit, and come to the conclusion that there are 4 potential suspect components in that system. Could be the sublimator, the gas trap, the condensate water relief valve, or the water separator. This week the crew is, or the team here on the ground is further troubleshooting and looking into those possibilities, as well as considering kind of what the next steps will be in their investigation. If you'd like to see that video again, it's been posted online on YouTube at youtube.com/realnasa. That's REEL NASA. Again, youtube.com/realnasa. You can find it there, and it's also been uploaded onto Facebook for the Johnson Space Center Facebook account. Another science experiment that Parmitano is taking part in again today is the ProK experiment, which investigates how what astronauts eat can predict and protect against changes in their bone metabolism while they're in space and once they get back to Earth. NASA studies the effect of spaceflight on bones in several different experiments, but this is actually the first experiment that looks at whether diet can be used as a countermeasure. The proposal is that a decrease in the animal protein to potassium ratio in an astronaut's diet will lead to less loss of bone mineral while they're in space. During their stay at the station, the crew members who are participating in this experiment go through 5 dietary intake sessions, 5 blood collections, and 5 24-hour urine collections. During the intake sessions, the crew member would eat either a high or low ratio of animal protein to potassium, and then take the blood and urine samples. And samples are returned to Earth for study. And all 16 crew members are to participate in the study, which started back during Expedition 21. If this works, it could be a very good countermeasure for astronauts because it doesn't require any extra effort for the crew, just an adjustment to their diet. That again is another experiment that is helping us get ready for future exploration. Again, as the journeys get longer and the distances from Earth farther, it's important that the crew stay healthy so that they'll be in good condition for exploration once they arrive at their destination.
Are we going to be doing
Yep, Karen, we're going to do the conference in a couple minutes, so just give us that time. We'll get everything configured.
Good, thanks.
Parmitano is currently in the section of the ProK experiment that requires him to carefully log his food intake while following the prescribed diet and taking regular urine samples.
And Station Houston, Space to Ground 2 for Luca. You are go to continue with the WSTA, Phil.
Copy.
You saw earlier some live video of Karen Nyberg and Chris Cassidy working to train for the upcoming arrival of the H-2 transfer vehicle from Japan. They've been spending quite a bit of time today and yesterday working on the robotic training that's necessary to get ready for that arrival. They'll be using the space station's robotic arm, which you can see here in this video recorded earlier this morning outside the International Space Station. They'll use what's called the end effector, basically the hand of the robotic arm, to grab onto the HTV and bring it in for a berthing to the station's Harmony node. They train extensively for that on the ground, of course, but want to have all that training fresh in their mind and to be ready for the HTV's arrival on August 9th after it launches this coming Saturday. Some more recorded video from the training that the crew took part in earlier today with the station's robotic arm, getting ready for their duties with the HTV. Yesterday we saw them working inside the Cupola workstation, and today they were in the Destiny Laboratories robotic workstation, training in both areas. And you saw there, this is a close-up view of the latching end effector, which is actually used as basically the hand of the robotic arm to grab on to the vehicle once it gets within range. Those 3 wires, as you saw, are used to, called snares, and used to close in on a grapple fixture that'll be on the vehicle, used to close around that and again guide the HTV in for its berthing to the Harmony node. The HTV launch is scheduled to take place on Saturday at 2:48 p.m. Central Time. You'll be able to watch it here on NASA TV with coverage beginning at 2 p.m. It's going to be carrying to the station experiment samples and equipment, including Frost, the freezing refrigerator of Stirling cycle, which is able to maintain a negative 70 degrees Celsius temperature and stay cool even without power. Also will carry what's called an ice box. It's an acronym for the ISS Cryogenic Experiment Storage Box. That's able to carry science experiments to the space station, again staying cool even without power during flight. And on board the HTV there will be another eyeball experiment just like the previous HTV. That's a re-entry data recorder that will relay information on the vehicle's return to Earth and burn up in the Earth's atmosphere when its stay in space is over. You can see some of the photos here of the different experiments and supplies that HTV will be bringing. In addition to those 3 different pieces of hardware, there's also supplies, food, water, and clothing for the crew aboard. And again, it'll take a little time to make its way to the space station, not arriving until August 9th, when it's scheduled to be brought in for berthing at the station's Harmony node at 6:29 a.m. Central Time. The crew is going to continue with their preparations for that arrival. In the meantime, again, training today, as you saw, at the robotic workstation to make sure their skills are fresh and ready to go on August 9th. Work has been going on to get the HTV ready for its launch on Saturday. We have some photos here taken inside the processing facility at the Tanegashima Space Center in Japan, getting the vehicle ready for its launch. Again, that's scheduled to take place on Saturday at 2:48 p.m. Central Time. Here it is being transported to the vehicle assembly building to be added to the rocket that will launch it into space. In the midst of all the science experiment work that's going on, Luca Parmitano also took some time out of his duties today to contact an Italian language school in Sydney, Australia, via ham radio. Crew on board the space station is often able to talk with students that way through opportunities arranged by the Amateur Radio on the International Space Station program, or ARISS for short. You can find out more about that program at arrl.org. Again, that's arrl.org. And the goals of the program include inspiring an interest in science, technology, engineering, and math, or STEM subjects, in other words, and also in STEM careers among young people. Another goal is providing an educational opportunity for students, teachers, and the general public to learn about space exploration, space technologies, and satellite communications. Also providing an educational opportunity for students, teachers, and the general public to learn about wireless technology and radio science. And it also hopes to provide an opportunity for amateur radio experimentation and evaluation of new technologies. Seeing now a live view from the cameras on the exterior of the International Space Station, looking down at the Pacific Ocean from a distance of about 257 miles up. The station's traveling southeast towards the coast of Chile, and we'll be passing over a bit of South America before reaching the southernmost point of this orbit and heading northeast towards the coast of Africa. some of the views that can be seen from the International Space Station provide a good excuse for the other experiment that the Expedition 36 crew members have the option of taking part in today. That's the Crew Earth Observation Program. As they have time, astronauts on board the station can take advantage of special opportunities to photograph specific features on the Earth as they fly over. The photographs record the Earth's surface changes over time, as well as dynamic events like storms, floods, fires, and volcanic eruptions. The images then provide researchers on Earth with key data for better understanding the planet. More than 500,000 photos have been taken thus far on the International Space Station, and several thousand by the Expedition 36 crew alone. Today they had several different opportunities to participate with a number of different interesting activities going on board on the Earth, including tropical storm Flossie in the Pacific Ocean, wildfires spreading on the western half of the U.S., a new ice island near Antarctica, floods in Thailand, and volcanic activity in several different places on the Earth. In addition to that, they had some specific targets that they were asked to capture if they had the chance. The first one was in Tanzania. That's Dodoma, the capital city of the country, which was a target chosen for the capital's city collection, an effort aimed at gathering photos from space of capital cities around the world. That particular one has a population of 325,000 and is near Lake Sulunga in Tanzania. Continuing their effort to capture capital cities, they were also asked to get some photos of Porto Novo in Benin. That city has a population of about 250,000 people and is located near the coast in the south of the country. And following that, they were asked to get photos of the Okavango swamp in Botswana. That's a freshwater swamp in the Kalahari semi-desert, supports riverine forest, and appears as dark fingers in the middle of the tan-colored desert from space. The area fluctuates slightly seasonally and strongly during El Niño periods, and is very rich in wildlife. It's also a major tourist attraction that draws photo safari tourists from Europe. For the end of the day, they'll also have opportunities to capture capital city photos of Johannesburg in South Africa. That's the largest industrial center in Africa south of the Sahara and the world's largest urban area not situated on a river, lake, or coastline. And they also have a chance to get some photos of St. Helena Island in the Atlantic Ocean. That's part of an effort to capture photographs of sites that Charles Darwin visited during his journeys on the HMS Beagle. His particular stop at St. Helena Island took place on July 8th in 1836, and he stayed there for 5 days to explore its geology. Then the final opportunity to take part in the Crew Earth Observation Program for the day will take place when the space station passes over the Kingman Reef in the Pacific Ocean. That's a 4-mile-long V-shaped atoll located in the equatorial Pacific, about halfway between the Hawaiian Islands and American Samoa. Many of the phenomena and locations on the Earth have been previously photographed from space, and some of those photographs can be seen online at the Crew Earth Observation website, which is eol.jsc.nasa.gov. In addition to all the experiments we've discussed going on the U.S. side of the station, there are also a number of additional experiments going on the Russian side of the station today, including the ARL experiment. Longer name for that is Influencing Factors of Spaceflight on Expression of Strains of Interleukin. And the idea is that this experiment will attempt to develop methods for controlled changing of the properties of recombinant producer strains of interleukin using exposure to germ cultures during space in spaceflight environments with various laboratory conditions. And the crew is also working again today, as they did yesterday, with the bioemulsia experiment. That's some research aimed at the development of a self-contained reactor for producing biomasses of macroorganisms and biologically active substance on the space station. Good view here of the Columbus Laboratory, which, as I mentioned earlier, is celebrating today its 2000th day in space. Originally launched to the International Space Station during the STS-122 mission on board Atlantis, and has been providing additional laboratory space for the space station crews since then. A total of 2,000 days now. It's the smallest of the laboratories on the U.S. side of the station and measures 22.6 feet by 14.7 feet. That provides it with enough room to house a number of different experiments, including researches in areas such as fluid physics, materials science, and biosciences, as well as the external facility that you can see here on the end of it, which has the ability to host space science, Earth observation, and technology experiments. It can also house, or it does house, about 10 refrigerator-sized payload racks devoted to the various science experiments that go on inside of it, including the microgravity science glove box that we see many of the astronauts performing various experiments in.
Station Houston on 2 for Chris and CSL troubleshooting.
We're coming up now on the end of today's Space Station Live. Coming up next on NASA TV, you'll get a look at some of the other activities going on at NASA centers around the country in the NASA TV video file. That'll begin at 11 a.m. Central Time, next at the top of the hour. And then you'll want to tune back in a little early tomorrow at 8:30 a.m. Central Time to hear flight engineer Luca Parmitano talking with some reporters here on the ground. He'll be speaking with the Italian TG1 network about his stay in space thus far. And again, that is going to begin at 8:30 a.m. Central Time here on NASA TV. That's what's coming up on NASA TV, and this is Mission Control Houston.